Hello and welcome to Maths Bolo YouTube channel. Here, today, we are going to discuss UPSC CSC Maths Optional Paper 1 2020 solution to problem 5C. In this problem, the statements is for what values of A, B, C is the vector field V that equals minus 4x minus 3y plus az I cap plus bx plus 3y plus 5z I j cap plus 4x plus cy plus 3z k cap irrotational. Hence express vector v as the gradient of a scalar function phi and also determine phi. Now this is the problem. So we are heading towards the solution to the problem. So solution is a vector f is said to be irrotational if curl f equals 0. That is, if curl f is equal to 0, then we say that vector f is irrotational. Further, we have to find the curl of vector v. So curl vector v is given as I cap, j cap, k cap, dou upon dou x, dou upon dou y, and dou upon dou z. Here it is minus 4x minus 3y plus az bx plus 3y plus 5z 4x plus cy plus 3z. So we have this as curl f, and the solution is 0. So in the left hand side we have 0, that equals I c minus 5 minus j 4 minus a plus k b plus 3. So we have 0 vector, that is 0i plus 0j plus 0k, and here it is I c minus 5 minus j 4 minus a plus k b plus 3. Now we have to compare the coefficients of I j k vector. So we have c minus 5 equals 0 or c equal 5, a minus 4 equals 0, so a equal 4, and b plus 3 equals 0, so b equal minus 3. Now further we have the gradient of vector v is equal to dou upon dou x I cap plus dou upon dou y z cap plus dou upon dou z k cap vector v. Sorry, here it should be phi because we are finding the gradient to or gradient of phi. Now this is given as dou upon dou x of phi I cap plus dou upon dou y of phi z cap plus dou upon dou z of phi k cap. Now this is equal to the vector. So we have vector v, and it is minus 4x minus 3y plus 4z I cap plus minus 3x plus 3y plus 5z z cap plus 4x plus 5y plus 3z k cap. Now we have to equate these two parts of, that is dow x upon dow phi upon dow x with this part, dow phi upon dow y with this part, and dow phi upon dow z with this part. Now further we have dow upon dow x of phi equal minus 4x minus 3y plus 4z. So here we have phi equal minus 4x square upon 2 minus 3yx plus 4zx plus f1 y and z. Here this is the f1 y and z is assumed as constant because we are integrating to get the phi. So this implies it is minus 2x square minus 3yx plus 4zx plus f1 y comma z. This is the first equation. Now other way to find phi is we have dow phi upon dow y, that is equals to minus 3x plus 3y plus 5z. So we have phi equals, or dow phi equal minus 3x plus 3y plus 5z dow y, and integrating it both the side we have phi equals to minus 3xy plus 3y square upon 2 plus 5yz plus f2 x comma z. So this is the second equation because f2 x comma z is constant quantity. Now the other part is dow phi upon dow z, and that is equal to 4x plus 5y plus 3z, or dow phi equals 4x plus 5y plus 3z dow z. So integrating both sides we have phi equals to 4x z plus 5yz plus 3z square upon 2 plus f3 x comma y. So this is the third equation. Now from 1, 2 and 3 equations we have to find the exact value of phi. So you can see that one or two terms are repeated in each of the values of phi. So we will take the exact solution to phi by finding the unmatchable terms which are not into, or which are not repeated, that is the phi becomes From first equation, we take these terms 2x square minus 3xy and 4xz. So we have these as minus 2x square minus 3xy plus 4zx. 4zx. And from second equation, we take as minus 3xy is already there. So we will take 3y square and 5yz. So it is 3y square upon 2 and 5yz. Now from third equation, we will take only 3z square because these are repeated terms. 4xz is already present here and 5yz is already present here. So we will take only 3z square upon 2. So it is 3z square upon 2. Now overall phi becomes minus 2x square plus 3 upon 2y square plus 3 upon 2z square minus 3xy plus 4xz plus 5yz plus c. Because we have f1, f2 and f3 are the constant quantities, so we have 6 terms plus c. So this is the answer to the problem. I hope you like these types of video of solutions to UPSC CSE Maths Optional Paper 1 and 2, and I request you to please be stay tuned with Maths Bolo YouTube channel for more such solution videos. Thanks for watching.